Space is vast, mysterious, and full of secrets that we are only beginning to understand. But there's one question that has baffled scientists and stargazers alike, a question that challenges our very understanding of the universe. It's a question that, no matter how much we learn, we might never be able to answer. So, what is it? Stick around, because the journey to explore this cosmic mystery is as fascinating as the question itself. At the heart of the cosmic mystery lies a question so simple yet so profound, it has baffled scientists and philosophers alike. It's a question that doesn't require complex scientific jargon to understand. It's a question that a child could ask, yet it's a question that even the most brilliant minds in the world cannot definitively answer. What is this question? Why is the universe the way it is? The simplicity of this question is its most striking feature. It doesn't delve into the intricacies of quantum mechanics or the theory of relativity. It doesn't require deep understanding of dark matter or dark energy. Instead, it's a question that can be understood by anyone who has ever looked up at the night sky and wondered, why do the fundamental constants of the universe, like the speed of light or the gravitational constant, have the values they do? Why is the universe fine-tuned to allow for the existence of life? To understand the enormity of this question, consider the fine-tuning of the universe. For instance, if the strong nuclear force were just slightly stronger or weaker, stars would not be able to produce the elements necessary for life. Similarly, if the gravitational force was slightly different, stars would not form at all. This fine-tuning suggests that the universe is delicately balanced, like a house of cards, where a small change in one constant could topple everything. But why is this the case? Why does the universe seem to be perfectly set up for life? The answer to this question is not straightforward. Some scientists argue that the universe is fine-tuned because of the anthropic principle, which states that the universe must be compatible with the existence of intelligent life because we are here to observe it. Others propose the existence of a multiverse, where our universe is just one of many, and the constants vary from one universe to another. In this view, we just happen to live in a universe where the constants are just right for life. However, these answers are not universally accepted and are still subjects of intense debate. This is the core question that remains unanswered, a simple yet fundamentally impossible question that continues to challenge our understanding of the universe. The vastness of space and the mysteries it holds have always captivated human imagination. One of the most profound questions about space that remains unanswered is whether it is infinite or finite. This question is not just a matter of scientific curiosity. It has deep implications for our understanding of existence and reality. If space is infinite, then the number of stars, planets, and potentially life-supporting worlds could be beyond comprehension. This idea suggests that life, perhaps even intelligent life, might be common throughout the cosmos. Conversely, if space is finite, it places a boundary on existence, implying that the universe has a defined structure and perhaps a purpose. The implications of space being infinite or finite touch on the very nature of reality. An infinite space suggests that everything that can happen does happen somewhere, somehow. This could mean that there are countless versions of Earth, with different outcomes for historical events, different versions of you, and different realities playing out. This idea, known as the multiverse theory, challenges our understanding of identity and individuality. It asks us to consider whether our reality is just one among an infinite number of possibilities. On the other hand, a finite space suggests that the universe is a closed system. This could imply that there are limits to what can exist and what can happen. It raises questions about the nature of time and whether the universe has a beginning and an end. In a finite universe, the Big Bang might be seen as the starting point, and the eventual heat death of the universe as its endpoint. This view of reality is more constrained, but it also offers a sense of completeness and closure. The question of space's infinitude also touches on the nature of existence itself. If space is infinite, then the concept of everything becomes problematic. It becomes difficult to define what is out there because there is always more to explore, more to discover. This idea can be both exhilarating and unsettling. It exhilarates because it suggests endless possibilities and adventures. It unsettles because it challenges our ability to comprehend and make sense of the cosmos. In a finite space, existence is more defined, but it also raises questions about what lies beyond the boundaries of the universe and whether those boundaries can ever be crossed. This question remains one of the most profound and unanswered in our exploration of space. Space is vast and mysterious. Scientists have been trying to understand its secrets for decades. However, many theories lack final proof. One of the most intriguing questions is the nature of dark matter. This invisible substance makes up about 27% of the universe. Yet, no one has directly observed it. Scientists infer its existence from gravitational effects on visible matter. They propose various particles like WIMPs, weakly interacting massive particles, or actions. Despite extensive searches, no definitive evidence has been found. The search continues with experiments like the Large Hadron Collider and underground detectors. Another puzzle is the origin of cosmic inflation. This rapid expansion happened just after the Big Bang. It explains why the universe is so uniform. Scientists rely on observations of the cosmic microwave background. These are relic radiation from the early universe. Theories suggest quantum fluctuations caused inflation, but the exact mechanism remains a mystery. Different models compete to explain the data. Each has its strengths and weaknesses. The fate of the universe is another unanswered question. Will it expand forever? Or will it collapse in a big crunch? The answer depends on dark energy. This mysterious force drives the universe's accelerated expansion. Scientists measure its effects through supernova observations. Yet, its nature is still unknown. Some theories propose it's a property of space itself. Others suggest it's a new type of energy field. Without more data, the question remains open. Future missions and telescopes may provide more clues. Until then, the theories remain unproven. Science, with all its advancements, sometimes encounters questions that are beyond its current understanding or methods. This is where philosophy steps in, offering a different perspective and a set of tools to grapple with these mysteries. One such question is the nature of consciousness. Scientists can study the brain, map its processes, and understand how neurons fire, but the subjective experience of consciousness itself remains elusive. This is not a failure of science, but rather a point where scientific methods reach their limits, and philosophy begins to offer valuable insights. Philosophers approach this question from a different angle. They ask, what does it mean to be conscious? Is it merely a product of complex neural processes, or is there more to it? They delve into thought experiments, like the famous Mary's room argument, which posits a scientist knowing all the physical facts about color but never having seen it. The question then arises, would Mary learn something new when she first sees color? This thought experiment challenges the notion that consciousness can be entirely reduced to physical processes, leaving room for philosophical exploration. Another area where philosophy and science overlap is the nature of space and time. Einstein's theory of relativity has given us a profound understanding of how space and time are intertwined. Yet, questions remain. Is time a fundamental part of the universe, or is it an emergent property? What lies beyond the boundaries of our observable universe? These questions are not easily answered by scientific methods alone. Philosophers can help frame these questions in a way that could lead to new scientific inquiries or interpretations. Philosophy also plays a crucial role in interpreting scientific data. For instance, the measurement problem in quantum mechanics has led to various interpretations, such as the Copenhagen interpretation, many-worlds interpretation, and objective collapse theories. These interpretations are not testable through experiments, making them a matter of philosophical debate. They shape our understanding of reality and guide future scientific research. Thus, the overlap between philosophy and science is not just about the limits of science, but also about the complementary roles these disciplines play in understanding our universe. In the vast expanse of space, scientists often encounter phenomena that challenge our understanding. One intriguing aspect is the coexistence of conflicting models, where multiple explanations attempt to describe the same observation. These models arise from different theoretical frameworks or interpretations of data. For instance, the nature of dark matter remains a mystery. Some scientists propose it consists of weakly interacting massive particles, WIMPs, while others suggest alternatives like actions or sterile neutrinos. Each model offers a different perspective, and without definitive evidence, they coexist, driving ongoing research. The behavior of black holes also presents conflicting models. The traditional view describes them as regions of space where gravity is so strong that nothing can escape. However, alternative theories, such as loop quantum gravity, suggest that black holes might have a more complex structure, possibly even allowing information to escape. These differing models highlight the uncertainty and the need for further exploration. Another example is the Hubble constant, which measures the rate of the universe's expansion. Different methods of measuring it yield slightly different results. Some scientists attribute this discrepancy to systematic errors, while others propose new physics, such as the existence of early dark energy. This coexistence of explanations reflects the dynamic nature of scientific inquiry, where multiple hypotheses compete for validation. Such conflicts are not unique to space science. They are a natural part of the scientific process, where different theories vie for acceptance until new evidence tilts the balance. This process ensures that our understanding of the universe is continually refined and tested. It is a testament to the resilience and curiosity of the human mind, always seeking to unravel the mysteries of the cosmos. The universe is vast, and our ability to measure it is limited by the tools we have and the boundaries we encounter. One of the fundamental limits is the observable universe itself. This is the region of the universe that we can see because light from these regions has had time to reach us since the beginning of the universe. Beyond this boundary, light hasn't had enough time to travel to us, making those regions invisible and unmeasurable with current technology. Consider the cosmic microwave background, CMB, radiation. It's the afterglow of the Big Bang, a faint echo from the early universe. Scientists study it to understand the universe's origin and composition. However, the CMB also marks the edge of the observable universe. It's like a wall that we can't see beyond, a limit to our measurement. We can't say for certain what lies beyond it, and that's a question we might not be able to answer with our current capabilities. Another limit is the precision of our instruments. Telescopes, spectrometers, and other tools have finite resolutions. They can only measure certain wavelengths, intensities, and distances accurately. For instance, the Hubble Space Telescope can see far into the universe, but it has a limit to how far and how precisely it can measure. New technologies like the James Webb Space Telescope push these boundaries, but they're not infinite. There's always a point where measurements become uncertain or impossible. This is a practical limit to our understanding of the universe. Humans have an innate desire to understand the world around them. This thirst for knowledge is deeply rooted in our psychology. It's what drives us to ask questions, seek answers, and make sense of our surroundings. When we encounter something we don't understand, it creates a sense of discomfort, a cognitive dissonance that pushes us to resolve the uncertainty. This is why unanswered questions, especially those about the vast and mysterious expanse of space, can be so unsettling. Consider the famous Fermi paradox, which questions the contradiction between the high probability of extraterrestrial civilizations and the lack of contact or evidence for such civilizations. This paradox has puzzled scientists and enthusiasts alike. It leaves a lingering discomfort, a mental itch that demands to be scratched. People have proposed numerous solutions, from the zoo hypothesis to the rare earth hypothesis. Each attempt to answer the question is an effort to alleviate the psychological discomfort caused by the lack of an explanation. This need for answers isn't just about intellectual curiosity. It's also tied to our sense of security. When we understand something, we feel more in control. The unknown, on the other hand, can be a source of anxiety. This is why, for instance, the idea of an asteroid impact or a gamma-ray burst can be so frightening. We don't know when or if they might happen, and this uncertainty can be deeply unsettling. It's not just the potential destruction that scares us. It's the lack of understanding, the inability to predict or control these events. This psychological discomfort can also drive us to create stories and narratives to fill the gaps in our knowledge. For example, the lack of evidence for extraterrestrial life has led to a wealth of science fiction stories, from friendly aliens like ET to hostile ones like the xenomorphs in the Alien franchise. These stories serve a purpose. They provide a temporary resolution to the discomfort caused by the unknown. They allow us to explore different scenarios and outcomes, giving us a sense of control in an uncertain world. However, these narratives can also become a crutch, preventing us from seeking out and accepting the truth when it does emerge. The human quest for understanding the cosmos has always been hampered by the inherent limits of our knowledge and perception. Our brains have evolved to navigate and understand the immediate environment, not the vast, complex, and often counterintuitive nature of the universe. This fundamental mismatch creates a barrier that may never be fully overcome. Consider the concept of infinity. It's a simple word, but the idea of something without end or boundary is incredibly difficult for our minds to grasp. This struggle isn't a personal failing. It's a structural limit of human cognition. Moreover, our knowledge is built upon the foundations of what we can observe and measure. Yet, there are aspects of the universe that may be inherently unobservable. For instance, the idea of a multiverse is a popular theory in modern cosmology. It suggests that our universe is just one in a vast number of universes, each with its own set of physical laws. However, by definition, These other universes are beyond our observational reach. This isn't just a matter of not having the right technology, it's a fundamental limit imposed by the structure of reality itself. Additionally, the language and mathematics we use to describe the universe may also be limiting factors. These tools are human inventions, designed to make sense of our immediate experiences. When applied to the cosmos, they can only take us so far. For example, quantum mechanics, the branch of physics dealing with the very small, is notoriously counterintuitive. It often defies common sense and our everyday experiences. This isn't a sign that our theories are wrong, but rather that our intuition may not be equipped to fully grasp these concepts. Lastly, there's the issue of complexity. The universe is unfathomably complex, and our ability to understand it is limited by our cognitive capacities. As problems become more complex, so do the tools and frameworks needed to understand them. At some point, these tools may become so complex that they're beyond human comprehension. This isn't to say that we shouldn't try to understand the universe. On the contrary, the pursuit of knowledge is one of the most noble and rewarding endeavors. But we should also be humble enough to acknowledge that there may be limits to what we can know. As we wrap up, remember the key points. The universe is vast and mysterious, filled with more questions than answers. Dark matter and dark energy remain enigmas, shaping our cosmos in ways we are still trying to understand. The universe's ultimate fate, whether it's a big freeze, a big rip, or something else entirely, is still a puzzle waiting to be solved. The question about space that no one can answer today might just be the discovery that captivates us tomorrow. So, keep looking up, keep wondering, and join us next time as we continue to explore the unknown and unravel the mysteries of the cosmos. Until then, stay curious.